Okay. So let's look at 10-4. We'll look at the odds. First of all, are there any questions on this worksheet that you guys want to ask? Anything that you guys were confused about? No? Okay, I'll quickly go over these then. That's going to be 42 degrees. And do you know why? Go ahead, Abby.
Yeah.
Exactly. The inscribed angle is always half the arc intercepts, right? Or the arc that's intercepted is twice the angle that's inscribed. Exactly. So if this is 160, I would gather this is also 160. Actually, no, I lied. I'm wrong. Why am I wrong? So this is 160, obviously. Let me get a highlighter out. That'll be a bit better. Okay, from here to here, let's highlight in yellow. It wasn't 160. I was off by a little bit. What should that be actually?
Well, I actually have a question, Sean. What
Mhm.
question like one? Do you want us to put like one half? Would you want us to
I probably something like that probably won't have much work because it's a very simple calculation. It's more conceptual, so probably not. Something that involves variables, yes, for sure. Because I want to see an equation. Leon, do you have a question? Or yeah, go ahead. Almost, it's 180. Oh, 200, yes. From N to M is 200. But I just want to do N to L. The reason I want to do N to L is because it's a semicircle, because the diameter cuts it in half. So then this part right here has to be 20. But yes, it is 200 all the way around. But we still need to know what N to L is so we can get the little sliver of LM. So now I have that little sliver. This has to be 10 degrees. So that was just a little more work you had to do. And then for 5, they want arc VU. So they want all of this right here. Well, if that's 30, let me get a highlighter out again. That's going to be 60. Come on, that's 60. Because that's double the angle that's inscribed. This is 180. Because that's a semicircle. So how much do you have left over for VU then? If you have 60 already taken care of, 180 already taken care of, how much is left over for VU? If you add it all up, that's 240, right? So 120 is left over. So it's just a lot of like arithmetic if you think about it, right? Just add up stuff. Not that hard. And remember, full circle's 360. Here's where I would want to see some work. Well, actually, it's pretty. That's not too hard. X plus 80 has to equal 180. X is 100. Y plus 95 equals 180. Y is 85. That's all. Remember, opposite angles are supplementary when you have an inscribed polygon in a circle. And then we did 8 on Zoom. These have to add to 180, so that's why M was 120. These have to add to 180, that's why K was 60 for that one. And then finally for number 9, this one's a little more work. Let's look at JK, because we're probably going to need to know that, I think. How much is left over for JK? You already have 54, you already have 130, you already have 110. So if you do the math, 130 plus 110 is 240. And then 54 is 294. 66. That's got to be 66 degrees. So use a calculator, mind you, but yeah, it's 66 degrees. So 3A, crap, hold on. Oh, yes, I got it. I'm good. 3A is actually all this. No, it's half of all that. That's a little tricky. You have to consider, what does 3A intercept? 3A intercepts MK, not JK, not MJ, but MK. So 3A intercepts MK. MK is 120, so you got to take half of that, which of course is going to be 60 degrees, and A is 20. And then 4B, what is that intercepting? That's intercepting JL. So 4B is half of JL. And what's JL? That's going to be half of 66 plus 110. That's 176. That's 88. So 4B equals 88. Again, use a calculator. B should be 22. So you get 20 and 22. So those are a little more involved. This is why it's good to do this in groups. So you can kind of like talk to each other about it. But remember, all the arcs have done 360. That's how I got 66. And then realizing, oh yeah, 3 intercepts this arc. Here's arc adds up to 120, half that 60, 3 and 60 is 20. Then this other angle 4B intercepts JL. JL adds up to 176. 4B is half of that, so 4B is 88, B is 22. So questions about that? No? Okay. That was a tough one. Probably there'll be something like that on the test. You guys can do it. It's not bad. It's not too hard, but you know, just have to make those connections. You can see the answers are right there. Okay. Let's talk about 10.5.2. Clear. Again, look at the odds. You want arc AB, that's 130. Remember, when you have a chord and a tangent, it's half of the arc it intercepts. The angle's half of the arc it intercepts. For number 3, if you have angle 1, so you want angle 1, that's gonna be 130 degrees. Again, it's half of the angle it intercepts. Sorry, half of the arc it intercepts. I gotta be careful with my words. The angle's half of the arc it intercepts. The arc intercepts 260, half is 130. So you 130 for both of those. For 5, what do you think this angle would be right here? Let me mark it up. What would this be right here? That just marked in green. How would I figure that out? How does it relate to 122.5? Right. And there's no, I'll call it angle A. Thank you, Abby. Yeah, it has to have the 180. So angle A is going to be 57.5. Is that right? Yeah. Yeah, 57.5. It's not 45 degrees because A is not a center. You're not told that. You have to be told that's a center. You can't assume based on the looks. But still, you have to be told that that's the center. So all I know that's 57.5. Of course, this is also 57.5 because it's vertical angles, right? So there's a theorem that states that that angle is going to be half of the average of those two. Sorry, it's just going to be the average of those of the two arcs, or half of the two arcs added up. So these arcs are being intercepted by angle A and the vertical angle. So if you multiply both sides by 2, you should get 115. X will be 70. Yeah. Think we're good there? 70 degrees. Okay. Okay, so we're going 5. All right, 7. These, like 6 and 7, they're a little strange. So arc PR, I'll call it minor arc. My arc PR is going to be 113 because everything has to have the 360, right? And X is going to be half of the difference of those two. When you have two tangents, or if you have two secants or a secant and a tangent, like for number 6, you have to do half the difference of those arcs. What's that going to be? That's 134, I think. So you're getting half of 134. I think I did that right. Is that right? 130. Yeah, half of 134. That's going to be 67 degrees. Cool? 67. Okay. Yeah, feel free to make corrections. These are all for your reference. And, you know, obviously, you know, submit homework if you haven't. Okay, we're good? Okay, cool. Let's keep moving. And then finally for number 9, find indicated measures. Well, it's angle 1's intercepting at 220, so it has to be 110. because it's intercepting an arc that's 220. Angle 2 is intercepting an arc that's 140. So it's got to be 70. Angle 3 is going to be half of 100 plus 60. Let me erase this so you guys can see what's going on here. So angle 3 is half of the sum of those two. That's why you get 80. Angle 4 is the same kind of situation as angle 3, but two different arcs. It's half of 80 plus 20. 80 plus 120, sorry. So you get 100. Okay. Good. All right. So I got two more I need to go over. Find the value of x. So remember the rule here is you do x times 12 equals 10 times 6. X is 5. Or for number 3, you can do x times x plus 8. Oh boy. Equals 6 times 8. That's going to be a quadratic. That wasn't as easy as number 1. That was number 1. Leona, go ahead. No, what do you mean? What order? Like the 6 and 8? Yeah, that does. Yes. Because x and 12 are part of the same chord, and 10 and 6 are part of the same chord. So x has to be multiplied to 12, and 10 has to be multiplied to 6. Yeah. Otherwise, yeah, it would be off. Yeah, because yeah, it's just part of the same chord. That's just part of the rule. There is a more fancy way of proving why this works, which I'm not going to do because it's a little too abstract. Well, plus I don't remember how to prove it. I have to look it up, but it's just more of just a formula that we want to follow. That's what we're trying to do here. And then we're doing some problem solving by doing some algebra, right? Like in this case, x times x plus 8 and 6 times 8, right? That's going to be x squared plus 8x equals 48. So x squared plus 8x minus 48. Oh, look at that, minus 48. By the way, for those who have TI-84 calculators, I have I think I have my cord here. I could actually hook you guys up some programs. So if you guys want a quadratic forming program and some other programs that could help, especially if you guys are moving on to Algebra 2 next year, I could. And also, if anyone who's doing, is anyone doing the SAT or ACT this fall? Some people know. Well, if you do, or this spring, I have something to help you with that. So I could hook you guys up later today, some programs. But yeah, you just would do this, x plus 12 minus 4. Because you got to find two numbers that multiply negative 48 and add up to 8. So x will be negative 12 or 4. Negative 12 makes no sense because you can't have a negative length, right? That would be weird. So we're going to ignore negative 12 and keep 4. 4 would make sense because you have 4 and 12 here. That multiplies to 48. 6 and 8 also multiplies to 48. So 4 is okay. Something like that we'll have on our test for sure. And that's where group work will help. Now, this is how the group work, I would suggest how you guys probably go about your group work. You may want to designate someone like someone that does the calculator work or does the Desmos work. Do you guys use Desmos much? Desmos, the website that graphs stuff? No? Oh, we'll show it to you. Okay, if you don't know about it. Oh, okay. Well, it's really cool. So Desmos, here we go. So it's just a graphing calculator that's free. And if you type in x squared plus 8x minus 48, you go probably should say y equals just as a good habit, but and if I zoom out, if you guys turn your phone, please, thanks. It finds the x-intercepts for you. Because that's the whole point, right? When you're solving a quadratic equation, you're setting it equal to 0. You're letting y be 0. When y is 0, that's an x-intercept. So you want to see where the graph crosses the x-axis. That would be the solutions to this equation. That's making a graphical algebraic connection, which actually is a big part of Algebra 2. When you guys take Algebra 2 in the fall, that's usually going to be the big idea, is that you want to make those kind of connections. Realizing that, oh yeah, okay, y equals 0 at the x-axis. Right? Duh, 0. And your sentence equation equals 0, so you make that connection. So that's one thing you can do also. You don't have to do factoring if you don't want to. You could use this resource. It's totally fine. Or you could even use a graphing calculator, which I have shown you guys before. I'll just show you really quickly. Yeah, if you just hit y equals and type in x squared plus 8x minus 48 and graph it. It doesn't show you the whole graph, so you'd have to zoom out from your window. And if you hit the trace button, it doesn't just go there exactly, but it gets you pretty close. See, it gets close to -12. Or you can actually do this. There's a menu here that actually enables you to find x-intercepts. I think maybe I'll spend a day with you guys on maybe Thursday to do that. You know, I don't know, just to show you how that works. So you can do that, or you guys will like this. Oh, I didn't put the programs in this computer version of the calculator. I do have a program that does quad form. I could give that to you guys later today. But yeah, those are ways you could solve quadratics if you're feeling like you're a little iffy on factoring. You totally can just let me go back. Yeah, you don't have to do this so you don't want to. You could just, once you have the equation, you can actually graph it and see where it crosses the x-axis. Yeah, kind of more the same here. This one you have to do 4 times 4 plus 5 equals x minus 2 times x minus 2 plus x plus 4. So you have to do that. That will be 4 times 9, of course, which is 36. This will be, oh boy, x minus 2, 2x plus 2. Then you have to FOIL that. That's 2x squared plus 2x minus 4x minus 4. Move everything over to one side. I think this should work out. If you factor out 2, yeah, this will work out just fine. And then continue breaking it down. You get 2 answers, 5 and -4. -4 is not okay because you're gonna have negative side lengths. So you're gonna have to stick with just 5. Which would make sense because you have 4 times 9 equals 3 times 12. That would make sense. Factor 5. So again, these are just more problems that kind of help you with problem solving skills. Questions on that one? And it's a little messy. But factoring wasn't too bad. But again, if you're struggling with factoring, you totally could take this equation or this equation here. Just punch this in the Desmos. That website showed you, Desmos, DESMOS. If you forget the name of it on Thursday, just ask. I'll give you the name again. Just punch it in, gives you the answer. So, but you have to make that connection, right? That's what I care about. Can you make that connection using the formula? And I'll give you all the formulas. I'll give you. I have to find a really good reference sheet. I think I'll try to find one by tonight or tomorrow, and then show it to you guys so you guys can use it on the test on Thursday. Okay, and then there's still another problem here. 7-9. This case, you're going to say x times x equals 9 times 9 plus 7, okay? So it's almost the same thing. It's just that this actually gets repeated because there's no secant. So there's no, it's all external. So you have to write like that. X squared equals 9 times 16. That's 144. That is 12. 7 is 12. Questions so far? Okay. Without fail, it's taking me about 10 minutes to each worksheet, but that's right. Okay. Fine for now. Oh, let me just see if you guys are still copying. You guys are good? Good, cool. 9. Lastly for 9. Yeah. If x, which of one is a positive I of x? Well, it can't be negative. Forget about that one. That's crazy. Well, let's work it out. It's going to be 2 times 2x plus 6 equals x times x. Remember, it's just what we saw earlier in number 1. You have 2 chords. So the way the chords are broken up, the products of those numbers has to equal the other product. So 4x plus 20 plus 12. Come on. Has to equal x squared. X squared 0 equals x squared minus 4x minus 12. 0 equals x minus 6, x plus 2. So x is definitely 6. Obviously not these two. You do get -2 as an answer, but remember, your side length can't be negative. That's why we get rid of it. So it's just 6. So I can ask them like that on the test. That's a good question. I think it's a fair question. It's not too hard. And the factoring is not too bad. It's pretty easy. And again, you can use Desmos or graphic calculator to solve. But yeah, we're okay. All right. Okay, one more. 10-7. This one I think is a little easier. I thought this was the easiest section of all the 4 we did yesterday. And just so you know, on a real geometry class, I would never teach 4 of these in one day. I would never ever do that. I'd probably do 1 per day. Like this you could do in a day. The other one, yeah. Like this is something we would do like over a week or 2 perhaps. And then the other half of chapter 10 over another week or 2. You know, usually do every 3 weeks you do a unit. So we are moving fast, obviously. Yeah, so anyway, the main formula is this: x minus h squared plus y minus k squared equals r squared. You already know what h and k are. They're 2 and 6. You already know r is a 16. Likewise for number 3. So you can say x minus 2 squared plus y minus 6 squared equals 16 squared, which is 256, by the way. Or here you're going to do x minus 5 squared plus y plus 4 squared equals 6 squared, which of course is 36. Center here is -2, 3, and raised is 5. Okay. For number 7, 1, 2, 3, 4, 5. Okay, so the center's 1, 2, 3, 4. The center's at 5, 4. And the radius is 1. So you can say x minus 5 squared plus y minus 4 squared equals 1. That's all. Or 1 squared, which is still 1 anyway. That's just like 1 and 3, just you have a graph. So you just extract the center and radius from the graph. Not that hard. And then lastly, for number 9, just do a quick plot. The center is at 4, 2. The radius is 5. So you go 5 away from 4. And 5 away from 2. Up and down. And then you can just got to fit pretty nicely. You make a circle. So yeah, those are those problems. Okay. So hopefully we're okay with that. We are going to do this later today. Probably just after the lunch break. Here we go. We are going to do this just to make sure you guys are getting this, and probably we'll do in groups again. I'll probably just mix up groups, but this will be good practice. Actually, I think what I might want to do, I might just kind of tell you what groups you're going to have for Thursday. I might tell you today, and that way you can kind of get practicing with those people. But I'm going to mix them up because it's going to mix groups up. We'll do this after our lunch break. So just make sure you guys are cool. Chapter 10 test review. Okay. One other thing I want to mention as well about the homework. Now that everyone has their test back, if you want to do corrections, please do so. The midterm test correction are due this Friday, as well as the Unit 4 test corrections. Okay. So Doom, I'll give you return half the points. You guys know what to do now. You know to make a video, you know to upload it, or share with me the link by email, whatever works for you guys. I think you guys, I think have figured out the tech stuff, so I'm not worried about that. But do it because I know Unit 4 did. Some people did well. Some people had some trouble with it. I do have all the videos up, so you can watch those videos if you need to. I think I could scan I do have my solutions for Unit 4 worked out. I might have the midterm solutions also worked out too. So I can scan those and put them up as well. So that's not a problem. And for those who are on Zoom, I'll scan your test and email it back to you, so you have that. They record some class. So like on Friday, I did go over the midterm. Sorry, the Unit 4 test that day, and I think I went over the midterm on July 8th, if I'm not mistaken. Let me just click on that. Title of the video should say midterm review. Yeah, so it's all there. So anyway. Okay. So let's move on. Okay. So we're just going to keep the train moving here. Let's go to chapter 11. So you guys should have the chapter 11. If you don't have it, for those who were not here last week, I have hard copies if you want them. Who wants the chapter 11 and 12? Yeah, a lot of you guys are kind of. Do you need chapter 10 also?
No.
Okay. Oh, do you need chapter 10 also? Maybe you need chapter 10 also. Can you need it? Yeah, okay. Do you need chapter 10 also? Okay. 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 Yeah, go ahead. Yes, everything. Yeah, everything. Yeah, that would actually get you. Yeah, right. Questions? Okay, good. All right. Good. All right. So let's talk about chapter 11. Okay. Chapters 11. We're still recording, right? Good. Okay, let me close these down. Too many windows open. Okay. So chapters 11, 1, 11, 2, 11, 3 look like it all deals with area. This should be actually, I think, pretty easy. 11, 4 looks like that's in circles. That's tomorrow. 11, 5 is more on circle or sectors. Okay, that's fun. And 11, 6, oh, that's also kind of fun one too. All right. All right. Interesting. All right. Those are gonna be a little crazy. We'll do it on Zoom tomorrow. All right, let me size this up. So yeah, my thinking is we'll do 11-1. We'll do the worksheet that follows. Then we'll do a break. Come back from a break. Should be able to finish 11-2 and 11-3. Lunch. Do chapter 10 test review. And if we can get all the work done, you don't have any homework tonight. You can watch the MLB All-Star game or do something else tonight. But if we do have anything we don't get to from the worksheets as well as the chapter 10 test review will be homework. All right, I don't like this. Just get rid of that. This right here, hopefully you recognize that you can combine like terms. That's just a good warm-up. Good warm-up solving equations, right? Equations with squared terms, right? X squared plus x squared is 2x squared. Divide by 2. What's x squared going to equal? 64. What's x going to equal in this case? Plus or minus 8. It's plus or minus 8 because it could be negative. That is a possibility. So we have to acknowledge that. It can be negative. Because if we're plugging negative 8 here, what's negative 8 squared? Negative 8 times negative 8 is 64. Negative 8 times negative 8 is 64. 64 plus 64 is 128. So it could be negative also. So that's just a little warm up. Look right below. Areas. You have an area of a square, area of a rectangle, area of a parallelogram, area of a triangle. They're all pretty similar. They're not that much. I mean, the only one that's really different is the triangle. And why would a triangle be half? If you think about it, if I drew this diagonal here for the rectangle, what does that diagonal do to that rectangle? It cuts it in half, right? And right now it's pH, so it's half pH, right? So if you think about it, the vertical leg acts as an altitude, and the horizontal leg acts as a base. So that's where that really comes from. Half of right. Parallelograms do the same thing. You call one of the sides B, but the height is not going to be one of the sides. The height is going to be a perpendicular segment connecting a corner, the opposite corner to the side that you call the base. So you have to have an altitude, just like you do for a triangle. But the rectangle, the side here, automatically acts as an altitude because it's already perpendicular. So by default, it has a dual purpose. It's a side as well as an altitude. And square, that's easy. All sides are the same. So S times S, right? Your base is one side, the height's another side. Always, always, always use the perpendicular measures for the heights, right? Always, always, always. And if the two polygons are equivalent, the areas are the same, right? Why would they not be the same? It's kind of like this tile here, right? Like, you know, you see like you have the yellow tile, brown tile, tile, but anyway, being a little don't mind me having not much interior decoration. But they're all equivalent tiles, right? So they're all the same area. Okay. Find the area of the polygon here. Really easy. You have a triangle, half times base times height. Parallelogram, base times height. Ooh, this one you got two things going on here. You got a triangle, half BH, and you got a rectangle. BH. Okay, so let's work this out. There's your base. There's your height. There's your base. There's your height. So you do 1/2 times 21 times 8. 1/2 times 21 times 8. That will be 84. That'd be 80. So questions on that one? That seems pretty straightforward. I think this will be a much easier unit than or much easier chapter than chapter 10. Okay, and then what about for the parallelogram? The base is 30. Yeah, it's just 30 times 17. That's it. Which will be 510 if you work that out. Again, use a calculator. So yeah, it's, and the thing with area, I don't know, it's not something you really use too much in algebra 2. I mean, it's good to know. It does kind of come back, like if you do standardized testing or maybe in pre-calculus or calculus, you might come back to this stuff. In real life, it's actually kind of good to know area in case if you do any work in your house, that's kind of good to know that. Actually, my brother, he was a real estate broker and as an agent. They were curious to know the square footage of a lot that was shaped kind of like a hexagon. I have to look up the problem. It was actually a really cool problem. Maybe I'm gonna put some extra credit for you guys. And it required some pretty nifty geometry to kind of, because they had to figure out the actual square footage if you want to price the house correctly, right? Otherwise, you might underprice or overprice if no one wants to buy the house. But it was an interesting shaped backyard. It wasn't like a rectangular lot. It was definitely, it's kind of hexagonal in a way, but had some other weird stuff. So it was kind of a cool problem. So this can be somewhat practical in real life. This one here, you have two shapes. Let's think about the triangle first. So I'll call this the base. I'll call this the height. I'll call that the base called height. I know the height, I don't know the base. How am I gonna figure this out? It's connected to a rectangle. Sean, go ahead. Pythagoras, yes, we're gonna do Pythagoras. Yeah, totally. Yes. See, this is 25, right? How do I know that's 25? Right, totally. So now you could do Pythagorean theorem, 100% correct. So there's a little bit extra work you have to do here. And I'll call this B for base. So you got to solve for B. I'll tell you right now, it's going to be 20. How do I know? How do I know it so quickly? Because it's a 3, 4, 5 ratio. Remember the 3, 4, 5 triangles? I'll do it on the board here. I know that's true. How do I know that's true? What's 3 squared 9? It's 4 squared 16. What's 9 plus 16? 25. What's 5 squared? 25. This is always going to be true. Are these proportional? Sure. 15 is 5 times 3. 5 is 5 times 5. 20 is 5 times 4. So it follows the proportion. So you could kind of get away with not having to do Pythagorean theorem if you can recognize that ratio. If not, do Pythagorean theorem, not a problem. Just takes a little bit longer. So now I know the base is 20. So it's 1/2 times 20 times 15, which should be 150. The triangle is 150. Okie dokie. And by the way, you can call 15 the base if you wanted to. One of the sides has to be the base. And then if it's perpendicular between the two sides, then the other would be the height. And that's easy. That's just 19 times 25. Which I think is 475, if I'm not mistaken. Don't do this in your head, please. I think it's 475. Thanks. So it's 625. If you can't really tell, usually when we go to a restaurant, I'm always the one that calculates how to split the bill or how to tip. Everyone always looks towards me because I just do this for a long time. Now everyone's got their calculators too, though. Or everyone just says, here's like 5 credit cards, just pick one or split it. But yeah, I'm usually doing it. But they always tell you now, I think, how much to tip anyway, which I don't know. Things kind of like, if you have like really crappy service, like, well, I'm not going to tip that much. But anyway, 625. All right. Ooh, that's a good one. All right. So here you're supposed to find the area of parallelogram PQRS. Oh, okay. It's not too bad. Okay. I was yeah. I don't know why they put this triangle here. That's weird. That's not even necessary. If you tilt your head, that's gonna be 12. All this is 12. Because the opposite side is also 12. Just 12 times 4 is 48. I don't know why it's drawn that way. I think it just made it mess with you a little bit. That 6 is useless. You didn't even need to know that there was a 6 there. All you need to know is that you have a base and a height. Base and height. 12 times 4. Okay, for 11.1.2, the base of the triangle is twice its height. The area of the triangle is 356 square inches. Find the base and the height. Okay. Okay. So 1/2 times your base times your height has to equal 356. Right? That's your base. That's your height. And you work it out. Those cancel. H squared equals 356. And what's root 356? Yeah, kind of weird number. 18.9. And make sure you label units. 18.9 inches. So the base is double. $37.7. Yep. So that's that one. And you guys are gonna practice just a little bit because you guys need to start moving around, and I gotta stop talking. So you guys gotta practice. Okay, so we're working on 11.1.2. Sure, no problem. Yeah, here. There we go. Yeah, we just got 2 more problems, and we're gonna do a worksheet, and after the worksheet, we'll do a break. Okay. So actually, let me do this. Yeah, go ahead. Yeah. Let me erase this here. Let's just clear it. There we go. Let's just move on. All right. You guys, we're almost done here before you guys do a worksheet. Okay, guys, quiet, please. Ben, thanks. All right. So, parallelogram. Area is 153. This is the formula BH. It's going to look like this, right? Here's the height, which is 17. The base, I do not know. The area I know is 153. And I know the formula. Oh, come on. 153 equals B times 17. Solve for B. 9. Yeah, it's 9. Yep. Not that hard. And then lastly, you have a barn. You're painting the side of a barn. And you have a gallon of paint covers 350 square feet. How many gallons should you buy? Actually, that is, yeah, in real life, actually, painters have to figure that out. We painted a couple rooms in our house just a couple months ago. They had to figure that out, right? So first of all, you're going to do 18 times 26 for the rectangle part. I do not know what that is off the top of my head. Oh, go ahead, tell me. 468, thank you. Okay. And then What do we have after that? The triangle part. This is a little tricky, but you see it's equilateral. Sorry, it's isosceles. And it's a right triangle as well. So I could say x squared plus x squared equals 26 squared. Okay, I'm gonna get my calculator out. Yeah, so you could do that. Okay. Okay, cool. Yeah, if I work that out, that's 2x squared equals 676. Divided by 2, I get 338. Root it. It's gonna be about 18.4. You guys can't read that. My bad. Let me erase the other stuff I'll put up here. Yeah, x will be roughly 18.4. So that's 1/2, and your base is 18.4. Your height's also 18.4. So square it times 0.5. I should get 169 actually. Add it up. You should get 637. So the side of the barn is 637 square feet. 1 gallon paint is $3.50. How many gallons should you buy from the store? Definitely more than one. Do you need 3? Or is that too much? Is 2 enough? Yeah, 2 would be enough. Yeah. You have some left over, that's fine. Maybe you need to touch up or whatever, but 2 would be sufficient. Yeah, and they actually do figure that out. Like, actually, carpenters, anyone in the trades, they're really good with this kind of stuff. They're really great at this kind of math. So definitely it's somewhat practical. So okay, so here's what we'll do. There is a worksheet on this. So we're going to do the break in a little bit. I said break at 10 o'clock. We'll do a break around 10:10. So we'll just kind of push things out just a little bit. But this is the worksheet that follows. I'll walk around and see how you guys are doing. But let's work through how many questions are here. I want to make sure not overwhelming with too much work. But you guys can totally get this done. Yeah, this should go by pretty fast. I'll put some hints up right now. Remember, area equals base times height. Area equals base times height. Area equals s squared. Area equals 1/2 times base times height. Same thing, base 1/2 base times height, but you have to solve for the base. It's not given to you. So you gotta figure that out. And we just saw this already. That's totally useless. And that's totally useless. That's also 20. Area is base times height. Okay, so we're gonna work those out, and then of course work out the ones that follow. I'll come around and see how you guys are doing.
Think so? Just
Yes, they that they would buy. Actually, it's whole thing are 17.
I know, but.
So it's like you want half. They get there. You do one half times 17 times 5. There's they will have to be there. Because the base of the triangle is always divided by the it's not necessary. You would. And then the differentiating rate of it. So once you get that, you should have
very small.
yeah, whatever. It is. Yeah, of course. We can add on. That would be- Yeah, you got it. That's it. Wow. Yeah, that's well. Yes.
How would you come to this?
Yep. I mean, if that, you're now the opportunities.
Oh, yes.
Okay, let's go over these and we'll do a break.
Here some Super Bowl football talk, so it means you guys are done. So let's go over this really quickly. Anyway, do you guys have a preseason Super Bowl pick that you guys want to share?
Lions.
What do you think? Okay, if you can't pick Niners, I do think Niners have a very good chance. I think the Bills are due. The Bills are due. Yeah. Yeah, my theory, except for Tom Brady, because Tom Brady is just like ridiculously good. My theory is that usually teams that have a young quarterback, like within the first 2 or 3 years, typically go to the Super Bowl because they haven't committed all that money to that person yet, so they still have the money for all the other players. Like Mahomes is never going back. I think he had his chance, and that's Rodgers hasn't been back since 2009. Breeze went once early in his career, so that's my theory. So I think I like Josh Allen. That's a good pick. I know he got paid, but they're still not on the hook for all that money yet. But I'd love to see Bills. Well, I grew up in the 90s where they lost 4 in a row.
Yeah.
And so I felt, I mean, I'm a Niners fan, you felt, and then I was hoping the Niners would play the Bills at least one of those 4 years. But yeah, no, you have to have a, they're like the Cubs. Like you have to feel bad for them. Yeah. Anyway, this one's gonna be 28. That was gonna be 14 times 12, which is 168. That's 225. Guys, go ahead, please. Let me finish. That's gonna be 65. Pythagorean theorem, I think that's 20. Is that 24?
Yeah.
Okay. And you gotta do half of 24 times 18, which would be, what's that? 216? You guys get 216 for that one? No. Number 5? Hold on. Pythagorean theorem. Yeah, you gotta do yeah, it follows the 3-4-5 ratio. And this one's just gonna be 160. That one. So 28, 168, 225, 65, 216, 160. I'll give you a chance to copy those down. Here, 1/2. Come on. Times 12 times x equals 36. 6x equals 36. X is 6. If that's 12, 276 equals x times 12. That should be 22, I think. No, 23. Is that right?
Yeah.
It's 23, yep. For 9, that's already 17. We got a triangle. And you got a rectangle. That rectangle is going to be 136, I think. And that's going to be 42.5. Add up. You get 178.5. And lastly, for this lawnmower, it mows 10 square yards in 1 minute. How long does it take to mow a triangle plot? So you got to do 1/2 times 25 times 24, which is 300, I think. And you're doing 10 square yards in 1 minute. So 10 square yards in 1 minute. So 300 square yards would take 30 minutes, right? Because you want to maintain that same ratio. So it'd be 30 minutes for that one. Does that make sense? Okay. So we'll take a little break. We'll come back at 10, say 10:30. Come back at 10:30. So we'll take a nice little long break, then we'll do 2 more sections. Oh yeah, sure. No one's a Cowboys fan here? You are? I was so I was so happy when we beat the Cowboys the way we did. That too, but I just did not like the Cowboys are so arrogant.
I don't like. I was losing.
Well, their owner, like, just like he meddles with the team so much. That's yeah. I cannot stand the Cowboys. That's like
The last one was twice in the 90s. That's not. They were so arrogant. Yeah, I don't think anymore Royal Giants saying something.
let me hear that. Oh, Nia, go ahead. You have a question. Okay, so we're gonna keep moving. Thank you for coming back, guys. Let's focus. So 11-2 and 11-3. Let's finish strong here. So we're gonna cover more area, but we're gonna cover now area of other shapes, trapezoids, rhombuses, and kites. They're still quadrilaterals, but they have their own unique formulas. So we'll go over those formulas, and then we're gonna practice using those formulas on this worksheet. Then we're gonna do 11-3. That's perimeter area of similar figures. So when you have diagrams that are similar, meaning the sides are proportional, there's a way you're going to go about determining the perimeter and area of another similar diagram. I'm going to talk about that technique and then do some practice there, do more practice. That should get us to a lunch break by about 11:30. We'll do a 30-minute lunch break, come back, and then we'll do just briefly for about 15-20 minutes, just to, and this most likely will be your homework, just to make sure you guys are still getting more practice with chapter 10 stuff, because I feel chapter 11 is pretty easy. Chapter 10 is a little more challenging with the algebra and the connections you have to make. So let's talk about the warm-up first, and we're recording. So yeah, I don't care for that. This is trig. We did trig in the previous unit. In case you guys forgot, if that's your angle, that's going to be your adjacent side, and that's going to be your hypotenuse. And also, hopefully you guys remember this mnemonic, SOHCAHTOA. So which one uses both the adjacent and hypotenuse? Which of those three options? Use both A and H. This is the first one? This is the last one? Definitely the middle one, right? So you're going to say cosine theta equals A over H. Well, you know the A is 13. You know the H is 18. Now you got to solve for theta. The problem is that theta is a part of the cosine, right? So you have to get rid of the cosine. How do we do that? How do we isolate that theta? How do we get rid of that cosine? We do a inverse, right? And it's in the calculator. I'll show you where it is in the calculator again. And that'll get you the angle. So if I go to the calculator, you hit second cosine, or you can go to decimals, or you can even just type in Google. I think it'll tell you. But if you do 13 over 18, and make sure you're in the degree mode, you should get 43.8 degrees. So that's a little warm up, because I know some of you guys had some trouble with trig. It will be on our final exam for sure, Wednesday of next week. So yeah, that's all. Just want to make sure you guys are comfortable with that. Now let's talk about formulas. Trapezoid, rhombus, kite. For a trapezoid, it's going to be 1/2 H, B1 plus B2. H is going to be the perpendicular second that connects two bases. Obviously, this is perpendicular, just look at it. And B1 plus B2 in parentheses. So if you want to derive it, it's kind of like having two triangles in a rectangle. This rectangle will be B1 times H. And if you were to combine these two here, it's kind of a weird scenario, but you wind up getting, assuming that if this were isosceles trapezoid, you would subtract B2 from B1 and split that difference between these two legs here. If you combine everything, just trust me, it comes out to that. So that's what that is. For rhombus, it's 1/2 D1, D2, so you have two diagonals, obviously. Diagonals are perpendicular. If you were to actually calculate the area of, like, say, this top triangle,
call that D2 is the base. The height would be half of D1, and you have half of that. And then do likewise for below, the triangle below, just the same as the triangle above. Combine it, you would get half D1, D2. And Kite same, it's the same exact. Again, you know that's D2, right? And this right here is half of D1. If you do 1/2 times 1/2 D1 times D2, you get a quarter D1, D2. But means you got another quarter D1, D2 right below. Combine that as half D1, D2. Same exactly with Rhombus. So,
but again, I'll give you guys a reference sheet and you guys can use your notes. And most likely during the lunch break, I will actually figure out what groups you guys can have on Thursday and then have you guys do the chapter 10 review after lunch break today. You may want to designate somebody like, hey, somebody get all of our stuff in order. Or someone's the recorder. Try to figure out roles that might help to streamline the work you guys do on Thursday. Just building to good teamwork, right? But I will give you guys a reference sheet anyway, but you might want to have someone who's kind of responsible for like sharing the formulas. So now just use them, right? that's all we do. We just apply these formulas to these problems down below. So here you got a trapezoid, right? Here you got a rhombus. And here you got a kite. Pretty obvious based upon the looks, but also the fact you have two parallel sides here. All sides are congruent for the second diagram. And a kite, you got two pairs of consecutive sides that are the same. And we use the word. So just plug away, right? You're just going to say 1/2 times the height times 8 plus 6. So it's 2 times 14 equals 28. Then here, you got to figure the diagonals first. Are the diagonals given to us? No. Can I find them? Yes. How'd you find the diagonals? If that's 30, what would be one of the diagonals? How long is that? That just drew. 60, good. The other diagonal, how long is this? That I'm tracing. 80, good. So that's all, right? It would have been actually kind of a cool problem if they gave you one of the sides and you had to use Pythagorean theorem, but that's okay. We'll make this kind of easy. So 1/2 of 60 times 80, which should be 240. And then same thing here. 1/2 times 14 times 6. That should be 42. We should state the units, by the way. We should state the units. I forgot to do that. That will be feet squared. So always square units. That's going to be meters squared. And that's going to be inches squared. And it's good to know the units. Maybe you guys know, maybe you guys don't know. Maybe you guys have parents or relatives who work in real estate. What's the one thing that really, well, there's a few things, but what's one thing for sure that impacts the sale of a house or home price? Go ahead, Neil. Okay. How big is perfect? And not just the inside, but also the land as well. But usually the inside kind of matters a little more because if you have a family of 5, family of 6, you probably want enough space, right? Who cares if you have a big lot, you have a small house? Then you're building 10, so you're gonna have to expand the house, right? And what units do you usually use to explain the area? Square footage. Because this country, we feel we're better than the rest of the world, so we don't use meters. Everyone else uses, like you go to like England or you go to like Mexico or wherever, or Canada, they use like kilometers per hour for the speed limit or other stuff. So we're a little more special here. We use feet. But yeah. So we use that system. But yeah, square footage, right? So like this room, for example, if I want to find the square footage of this room, I would just get a measuring tape. It's pretty much rectangular, right? Measure that side, that side. So we just want to make sure we understand the units too, that it makes, you know, some sense to us. I mean, these are not word problems. Obviously, these are just very bland problems, but you know, area is kind of a big deal, right? It's and yeah, I mean, you know, home prices are pretty much bound by square footage. It's kind of you know, kind of impacts, and it's, you know, also impacts, you know, if you want to sell your house and make money, or you want to pull money out of your house and do a remodel, kind of a big deal to know how area works. So one diagonal of a kite is twice as long as the other diagonal. Okay, great. The area is 72.25. Okay, so you should draw. Whenever they describe a shape and you don't have a diagram, make one for yourself. Make a diagram, because it's gonna be so much easier to do the problem once you can visualize it. So one diagonal is twice the other. Okay, so here's one and here's the other. Do I know the length of either diagonal? No. So I'm going to call this first one here. Actually, that's kind of confusing. Let me highlight it. Let me highlight that. Okay, that's much better. And maybe let's use a different. Let's use black. Okay, so that I'm going to call X. I don't know what it is. Give it a variable. I don't know. Okay, then let's use a different highlighter. Well, I don't know that one either. But what variables, or what should I call that in terms of X? Knowing it's twice as long as the other. If the first one's X, what would the other one be? It's twice as much. 2X, very good. That's it. That's all you gotta do. And what's the formula? It's given to you up above. D1 half D1 D2. Sorry, kite half D1 D2. So there you go. That's problem solving skills. Whatever you don't know, give it a variable, call it X. The other thing you don't know, see how it's related, right? They tell you it's twice as long, make it 2X. And use the formula. So that's just problem solving skills. So area is 1/2 D1 D2, right? 1/2 D1 D2. So you got 72.25 half of X and 2X. And then they solve away. Then you use all the skills, like all that time you guys spent Algebra 1 last year, right? Or whenever you did Algebra 1, or middle school, you did some algebra, right? You should have to do a bunch of problems that ad nauseum, like there's so much you gotta do. You know, if you want to, this is a skill set to help you with the future problems, right? Now it's a skill set that should be second nature. How do I solve this? Well, I can cross out the halves and combine the X's. And then I square root both sides. That's how you undo the square. And whatever that is, 2.25. I think it's 8.5. Yep, 8.5. So one diagonal is 8.5, and that's inches. And the other is 17 inches. But again, draw. Totally essential, I think. Especially for those who are, you know, doing standardized testing. Who are rising juniors next year? Yeah, most of you guys will totally do the PSAT. You guys did the PSAT at the school, I think. Yeah. So I mean, it's not a big deal. It's a practice test for the SAT, and maybe you don't even need the SAT if you're planning to go to UC or Cal State. They're going to look at it, so you probably don't need to worry about it. But if you do, and you see a geometry problem, good to draw. It's a good strategy. Let's do it again. Let's try this again. So again, I don't give you a diagram, make one. It's trapezoid. Trapezoids look like that. The area is 90 square feet. The base is 4 times as long as the other. Okay, I didn't do this to scale. That's okay. So if this is X, then what would the other base be? If it's 4 times as long. What was that? Okay. No, that's a parallelogram. The area of a trapezoid is going to be 1/2 H B1 plus B2. And again, one base I don't know, so I'll call it x. The other is going to be 4 times much, so I'll call it 4x. And the height is given. What's the height here? 6. So work it out. 90 equals half of 6 and multiply it to x plus 4x. So problem solving skills, right?
You have this formula, let's memorize it. In fact, on the SAT, they give you this stuff.
For ACT, like for a particular problem, they'll give you the formula right next to the problem itself. So don't have to worry about memorizing. I don't care. I think memorization is terrible. I hated biology, biology, all memorization. Was much better in chemistry and physics. I just can't stand memorization. So yeah, I'll give this to you. But you got to draw, right? You got to use the skill. Let's draw a diagram. Okay, I know how a trapezoid looks. I don't know this side called x. That's 4x because it said so. I know the height 6. Plug away and then do the algebra. If I do the algebra, you should get 90 equals 3 times 5x. Half of 6 is 3. And x plus 5x, sorry, x plus 4x is 5x. 90 equals 15x. Use a calculator, x should be 6. So the length of the one base is 6 feet. The other base is 24 feet. Yep, that's all. Any questions? No? Okay. I won't move the screen. Why don't you guys try 11.2.3, the one right below. You're asked to find the area of the park. And you know that each grid square represents 10 square meters. So this then would be, how long would that be? 3, 4, 5, 6, 7. That'd be 70. It's 7 grid marks, but each grid mark is 10 meters. They said so, right? And then this was going to be 40, I think. That's going to be 50. And you're going to use this formula. So work it out, tell me what you got. Hope you got 2750. Square meters. So 2750 square meters. Okay. Does that make sense? Good. Okay. Still got another one before we do a worksheet on this. Give you guys a chance to copy. And then we will move on to the worksheets. Okay. Kind of clear? So last one, find the area of the shaded region. It's all shaded. Okay, so you have a rectangle. And you got a trapezoid. We'll start with the rectangle. Easy, right? 50. Trapezoid, 1/2 H Okay, so what do you think? What do you think this H would be right here? If it's 7 from here to here and 5 from here to here, what would H equal? 2, perfect. And if one of the bases is 7, I'll call this B1, then what would B2 equal? If that's 10, this has to also be 10. There we go. Not that hard. 1/2 times 2 times 10 plus 7. You should get 70. And add it all up, the whole thing is 120. Right? Because you got these two guys here. Whole thing's 120. Okay, so now we're going to do the worksheet on this. This is right here. So you guys did great on the last worksheet. You guys got through it pretty quickly. I'll give you guys some hints for the first 6, and then we have some algebra problems that follow, and some word problems. So I'll give you guys some hints here. So area is 1/2 times H. You're going to do that for this problem and this problem, just so you know. Here, area is 1/2 D1 times D2. Likewise over here. And likewise right here. And then this one is going to be same thing there. You do need the height. We do not know. But you do have yourself a right triangle, right? Hopefully by moving it off to the side, it's pretty clear what you gotta do. I'll just let you guys figure that out. So you have those hints there. So go try those 6. Talk to each other, call me over if you're stuck. Then you got some algebra problems that follow and some word problems. So we'll spend maybe about 8 to 10 minutes. Shouldn't take too long.
Number
5, it's 1/2 and what?
D1, D2.
Oh,
Yeah.
Let's go. It's the only thing that's happening to go. Wait until
It's that kind of symmetrical.
Oh, right. Yeah, we had.
Yeah.
I have a question on number 5.
So, next question.
You can't, find the weight.
So how long is this?
Thing.
So how long is this diagonal? The horizontal
What
one.
about 5?
So 5, this is gonna be 5 also. That's because the kite will always cut the diagonal in half.
Oh,
Actually, you're both going to 2 diagonals. So this diagonal is 16. This diagonal is 10.
Oh, okay.
So you should get 80 for that one.
Okay, let's go over it. So I was working on some of the solutions. Got carried away with another problem set. All right. So really quickly. Okay. So you're seeing 1/2 times 10 times 18, which would be 90. Here you're doing 1/2 times 10.6 times whatever that adds up to. I trust you guys can plug in your calculator just fine. So actually I'll just tell you right now what I got. 8.9 plus 13.7 times 10.6 times 0.5. That's a 10.6, so it looks like a 7. So you should get 119.78. This one here, that's gonna be 13. That's gonna be 24. So you 1/2 times 24 times 13. That should be 156. This will be 19. This will be 15. That'd be 142.5. This is 16 this way. That's me 5. The kite will cut one of the diagonals in half. So it's 1/2 times 16 times 10, which should be 80. This will be 1/2 times 7. Nope, that's gonna be 15, by the way. You have to solve for that. So you have to do Pythagorean theorem to get the height. And you have 9 plus 27. The other base is 27. Divide by 2, you should get 270. 270, 80, 142.5, 90, 119.7, 156. Question on any of those? All those guys make corrections? You have to make corrections. Okay. We're going clear. These here, some algebra. 330 equals 1/2. That's 15, and that's x, because diagonals bisect each other for a rhombus. This is a rhombus because all 4 sides are the same. So 1/2 times 30 times 2x, because you have x and x. That should be 330 equals 30x. X is 11. Here you're going to have 196 equals 1/2 times the height times the sum of the other 2 sides. Half x of 49. Solve for x. Should get 8. So again, these are the kind of problems that could ask on a test. They're very good problems. Require some algebra skills. Oh boy. Okay. Don't give us too much information, do they here? Well, I assume this is also 5 because it's a parallelogram. That's also 4. That's a tough one. That's 5. Oh, I see these markings here. These are 4 and 4. Okay, those markings helped. Guys, quiet, please. Thanks. That's 3 and 3 using Pythagorean theorem. So you got a rhombus. Half of 8 times 6. That's going to be 24. And then for the oh, that's not too bad. I got this. That's also 3. So for the parallelogram, that's BH. The base is 4, the height's 3. To get 12, all that adds up to 36. Yep, because your base is 4, height's 3. Yeah, that was kind of a crazy one. And then this word problem, the lengths of the bases are 10 and 14. And the height's 8. You can wash 6 square feet of the window in 1 minute. Okay, so let's find the area. It's not hard. 8, 1/2 times 8 times 10 plus 14. 4 times 1, 24. Which is 96. And you could do 6 square feet. Oh, you guys can't see that. Let's go to red. Six square feet you could do in 1 minute. So 96 square feet. If you do the math, 96 divided by 6 is 16. So it'll be 16 minutes. That's because 96 divided by 6 is 16. So it takes 16 minutes. Okay, so questions on 9-10? Sure, I'll leave it up for a little bit. And then what we'll do is we'll talk about 11-3. I'll talk about the conceptual part. We won't do the worksheet on it before lunch because I think you guys need lunch break in the next 10 to 15 minutes. We'll talk about after the break. But yeah, so that 9 was that was pretty tricky. Number 9. Yeah, so you have to see that that height of the parallelogram is gonna be this. I was trying to look this way. I was like, that's too hard from that way, but I saw realized, oh yeah, I know that height is gonna be the same as that. So 3 times 4 is the base. Base is whatever the perpendicular segment, whatever the height is perpendicular to, that's in your base. And this is 3. That's Pythagorean theorem. And I realized these are the same as that. Markings. Markings when that was 4, that's 5, that's 3, 6, and 8. Half of that's 24 plus 12. 10 was pretty straightforward. Just you had to use proportions after you found the area. If you could wash 6 square feet of window in 1 minute, then it would take you 16 minutes. And this is also kind of good to know because if you like have a business where you are window washing, some people do that for the houses and you charge by the hour. You want to make sure you get paid right for your time. So that's kind of a good practical problem there. Okay. So let me briefly talk about 11-3. Okay, so this is permanent area of similar figures. Get rid of that one. You want to solve for x, and you have 2 angles. It's up to which angle you want to use. Let's say I use this angle here. Remember SOHCAHTOA. SOHCAHTOA. The 20 is adjacent, right? The x. Is the x hypotenuse or opposite? Hypotenuse, right? So which one are you gonna use? So, ka, or toa? Which one? Which one uses A and H? Ka, good. You could have done the 25 degrees also, but then you have to use sine. The opposite of hypotenuse. So it's up to you. So you would change the angle. And that's 20 over x. If you do the algebra correctly, you gotta multiply both sides by x. So x times cosine of 65 degrees equals 20. X will be 20 over the cosine. Whatever that is. What's 20 divided by cos 65? 47.3. Okay. Questions there? Oh, okay. All right, let's talk about the concept here. I'll give you guys a little break. The concept is a little tricky. So you have two diagrams that are similar, right? Remember, similar meaning the sides are proportional. Well, naturally speaking, if you know the ratio of two sides, the perimeters will also be the same ratio. So actually, before I talk about that, what we want is to focus on the two sides, A or B, when you try to compare the perimeters. If you're trying to compare the areas, you have to A squared and B squared. Let me do a practice problem so you kind of see how it works. And then we'll take a break after, and we'll come back to these notes after the break. So you want to find the ratio of the perimeters, right? And you have these two sides here. And you told A, B, C, and D, F are similar. So what I'm going to do is I'm going to take DF and rotate it, so they line up a little better. So I'm going to rotate DF. So I'll put F here. I'll put 12 here, E here, and D there. So I took this and rotated it just so they line up better, because BC and EF have to line up. BC and EF have to line up. So the ratio of the perimeters is just 8 to 12. Or 2/3. The ratio of the areas is going to be this. Or 64 over 144. Which I think that can reduce. What does that reduce to? I think 4/9. Yeah, 4/9. Which really is that squared. That gets you 4/9. Now, why do you square when you try to find the ratio of the areas? Why do we square? Let me do a little thing off to the side here. What if I have two triangles? Or two right triangles, to say. And I got another one like this. Okay, before I do this problem, let's talk about the area of this room. I'm just going to throw a number out here. What if this is like 20 feet wide? What if this is 30 feet long? What would be the area of this room? If this is 20 and 30. What's 20 times 30? 600. So 6 square feet. What if I doubled this side here? That's 40. What if I doubled this length? Now it's 80. So now I got, sorry. I confused you guys. I apologize. We had 20 by 30 originally, the area is 600. Okay, if I double that, that's 40. And if I double this, that's 60. Sorry, I said 80. My bad. What's the area now? 2,400. The area did not double. The area quadrupled. Why did it quadruple? Because I doubled two sides. What's 2 times 2? 4. So whenever you're dealing with area, whatever ratio you have between some of the figures, you got to square the ratio. You have to square it. So like this case here, if I found this area, I know it's 6, but this area is going to be 24, right? Because if I do half of 3 times 4, I get 6. Half of 6 times 8, I get 24. So just because you double one side, all the other sides get doubled. So it means actually a quadruple. What if I triple the sides? Now the area goes up 9 times as much because you got to do 3 times 3. So we call this a scale factor. This is called a scale factor. The scale factor is simply the ratio between 2 sides. If you want the ratio of the perimeters, just use a scale factor. If you want the ratio of the areas, you got to square the scale factor. We'll talk about this after the break. Where we'll do these problems. We'll talk about the scale factor. We'll look at the worksheet that goes with it, and then we'll talk about the chapter 10 test review. So we'll let's come back at 11:55. So let's come back about 5 minutes before 12, so I can finish this off, and then talk about the chapter 10 test review stuff. All right. So let's take a break. I know you guys need to get some food in you or walk around. So we'll do another break. We'll come back in about 30 to 32 minutes. What's up? Okay, so let's talk about the rest of 11.3. Kind of help you with understanding the ratios of similar figures when looking at areas and perimeter. So let's look at 11.3.2. Looks like you have a floor plan for 2 different rooms in a house, a bedroom and a den. You're installing the same carpet in the bedroom and den. The floors of the rooms are similar. Okay. So I don't know this side, right? Nor do I know this side. But I do know this is 10, and that's 14. So the ratio or the scale factor, let me write that better. All I'll do is a text box. The scale factor is 10 to 14 or 5 to 7. So that's the scale factor. So basically, whatever this is, you multiply by 5 7 to this side, or vice versa, right? You know, this is like 20, you actually multiply by 7 things, right? So you can do a proportion to figure out the remaining sides. The carpet for the bedroom costs $225. The carpet sold by square feet. So what you're going to do is this: the cost of the bedroom, or over the cost for the den is not going to equal 5 to 7. It's going to equal 5 to 7 squared. Because you're dealing with area. Okay, we're dealing with area. So the cost of the bedroom I know is $225. Right? I'll call this X. And that's going to be 25 out of 49. If you solve for X, what's that going to be? Whatever 49 times 9 is. 441. So it costs that much. I mean, of course, a person who's giving an estimate, they'll measure both rooms and they have their cost per square foot that they have, but still, you can figure out that way as well. So it'd be 441. But you have to square it because it's dealing with area, not it's not one dimensional, it's two dimensional. So you have to square the scale factor. So let's try this again for the one right below or the next page. The perimeter triangle ABC is 16 feet. This area is 64 square feet. The perimeter triangle DF is 12 feet. Given that these are similar triangles, find the ratio of the area of triangle DF, and then find the area of triangle DF. Okay, so perimeter. Let me clear. I need more space. So the perimeter of ABC over the perimeter of DF is going to be 16 to 12, or 4/3. Okay, or 4/3. Okay, and that's going to be the scale factor. Because perimeter is one dimensional, right? Like for example, what if you had a triangle like this, right? You don't have to draw, you don't have to write this down. And what if you had this? Are these similar triangles? Yes. All the sides are proportional. What's the perimeter of that first triangle? 12. What's the perimeter of the other triangle? 24. See how the perimeters are also in a 2-to-1 ratio? Because they're one dimensional. So the perimeter is a scale factor. So then if you're dealing with area, they ask you to find the ratio of the areas. So it's going to be 4/3 squared. So the area of ABC over the area of DF will be 4/3 squared, or 16/9. And then actually got to find it. So let's do it. So you're going to do area of ABC, 64. You don't know the area of DF, so call it X, equals 16 to 9. If you solve for X, you should get 36. So that's the kind of problem I put on a test, something like that. Where you have to figure out, okay, the ratio of the perimeters is a scale factor.
Oh, because then if I square that, that's gonna be the ratio of the areas. Okay, I know what areas. So there's a lot of connections.
Yeah, this one. Not a lot, but multiple connections for sure. Questions on that one? Okay, you guys will need to obviously practice it. So we'll practice in just a little bit. So given the sum of polygons, find the unknown area. Okay. And then we got another one right there as well. Let me change. I'll leave this up in case you guys are still copying. So the scale factor here is 10 to 8. Or 5/4. Okay. So you're going to say this. Okay, I do need more space, so let me erase this stuff here. So you're going to say 150 over X equals 5/4 squared. You have to square the scale factor and deal with the area. Okay, let's square the scale factor. If you work it out, you should get 150 over X equals 25 out of 16. And I know you guys can cross multiply and do it, so I'll just give you the answer. It'll be 96. I was able to figure that out in my head because I
6 times 25 is this, 6 times 16 times 6. That's why.
I didn't actually cross multiply. I just kind of used some mental math there. But yeah, that should be 96. So let's try this again. Scale factor here. So now, with the repetition, hopefully you understand what scale factor is, just the ratio of the sides. 2 to 6 or 1/3. But since you're dealing with area, you're going to say area of the first triangle, which I know is 2. The other triangle I don't know, called x, equals 1/3 squared. Or 2 over x equals 1/9. X will be 18. Should be 9 times as much because the perimeter, the scale factor is 1 to 3. So again, that's scale factor. Okay. So why don't you guys try this one? So again, scale factor is going to be 15 to 20. Or 3 to 4. And we don't know this area. But you do know the other one. The bigger one, obviously. Okay. So try it.
Do the alphabets, make sure you come up with the alphabet, and we'll do the worksheet after.
And the chapter 10 test review will be the homework. We're not going to get into that today because I do want to finish by 12:20. I still didn't figure out what your groups will be on Thursday because I was busy working on a calculus assignment for another student. So I'll let you guys know. Maybe by tomorrow, I'll let you guys know. But definitely the chapter 10 test review will be homework. That's the end of the chapter 10 packet. Because we're going to finish the chapter 11.3 worksheet before we leave today. What do you guys get for X? So say again? Yeah, I agree. Good, 135. Yeah, 135 square centimeters. Let me show you how Spencer got it. So x over 240 equals 9 out of 16. 16x equals 9 times 240. I can erase this stuff now. 9 times 240, I believe, is going to be 2160. I think that's right. Hold on a sec. Yep, and then divide by 16, you get 135. Yep, very good. So that's the kind of problems you would do. And you're told that these are similar. You have to, I mean, this is assumed, but I'll tell you that. Okay, questions before we do the worksheet for about 10 minutes before we leave? No? Okay. Let's do the worksheet. So here's a worksheet. You're told these are all similar. So given the similar polygons, find the unknown area. So I'll kind of help you with the setup. So 14 out of 20 squared equals x over 400. We're here, 7 out of 9 squared equals x over 210. We're here, 24 out of 9 squared equals 1024 over x. And those are going from left to right, right? And then 5 over 3 squared equals 40 over x. It probably would help for your arithmetic to maybe reduce that if you can. So 7/10 might help, or maybe reduce that to 8/3. You know, just might be a little easier. So, all right, have at it. Sorry, Will, thanks. Okay, so let's try those 4 problems, and then try the ones right below as well. I will work out the chapter 10 test video solutions. The answers are at the end, but I'll work out the solutions later today. So you guys can see how these work.
Well, you showed the work on them as well.
Yeah, oh yeah, that's the homework, yeah, for sure. Yeah, so it's a lot of just cross multiplying and solving for x. Of course, you have to square the scale factor too. You got to do that first before you cross multiply. Yeah, go ahead, Shane. What was that? Yeah, that's fine. Yeah. Yeah, what do you get for number 2? Yeah, it's gonna be kind of weird. Yeah. Yeah, not all of them will always be whole numbers. I think I did this right. I hope so. Let's just double check the odds. Okay, good. But if you ever just give my answers, you know, obviously I'm human, I can make mistakes. Let me know. If you ever think and my answers seem off. Mosey on down to the other problems. Here we talked about this already. Actually, I haven't really done this. This is kind of backwards a little bit. You can say 135 out of 15 equals 15. I'll call the side x here. We haven't really done that. That's kind of interesting. The area is the scale factor squared, right? Your scale factor, we don't know. If you work this out, I think that's 9. You have to square roots. So x is 5, which would make sense because if the ratio to errors is 1 to 9, then the side lengths are 1 to 3. Yeah, it's kind of the same thing over here. Like I'll call this x. So if you have 7 out of 28, so you would say that. So 1/4. So x would be. Does that make sense? Wait. Hold on a sec. Oh, x squared. Duh. Sorry. So x squared equals 64. X is 8. Yeah, I have to square the x. Also forgot to do that. Or you could square rooted. That'd been fine too. Yeah, these here, the ratio of areas. So you just square root in each case. 4 to 9. Ugh. I don't know what that is. That's 5 over root 195. That's weird. That's 12 over 7. You square root to get the ratio of lengths. And then you're trying to raise money, blah, blah, blah. You plan to have some supposed to be increased length by 6 feet. Increase length to 6 feet. Okay. Well, I don't know which one's the length. Let's assume that's the length. So if you triple the length, area is 9 times as much. So if the area is 8, multiplied by 9, you get 72. I'm assuming 2 is the length. They didn't really tell us. So, but yeah. Okay. So we'll end there for today. We'll do more review of this tomorrow. Because I'm not going to rush it a little bit.
The chapter 10 says we will work all close to the school G by I guess around 1 o'clock. I told you before that, but by 1 o'clock I'll close the school G. I'll also work out the key, the solution key for the chapter 10 test to see how that's going. We'll talk about the cloud on Zoom tomorrow. We'll do the rest of chapter 11. I'm going on by 11:06 tomorrow.
We'll talk more about this. Also talk about our test that's coming up this Thursday, which is on chapters 10 and 11. So, all right, we're all set.